So first look at dilation. So dilation is defined using this equation here. Let S be this small region of ones with the origin in the middle. S sub B means translate S to a pixel where I have a 1 in this binary image B. So I center S at the location of a 1, and I take the union of all the pixels in S, which would be like this 3 by 3 region. Then I center it at another 1, and I take the union of that with this, and so forth. So essentially what I'm doing is I'm sweeping S over B, and everywhere the origin of S is aligned with a 1, I OR S with B. So to do that for this image, let me mark the locations of the original ones. So I center it at the first one and OR S with B, so that's this 3 by 3 region. I center it at the second one, I OR S with B, centered the third one, OR S with B, centered at the fourth one, I OR S with B. So that would be the output of a dilation. So that expands regions. So here's an example of applying a dilation to this binary image of characters which are kind of broken and thin, and the output is the characters that are much thicker. Erosion is the opposite of dilation. It's defined with this equation, which says shift the structuring element, the pixels of the structuring element, all over B. Wherever they are completely inside B, output a 1. So essentially, I sweep S over B. Wherever S is completely inside B, I output a 1 at the origin of S. So let me mark the positions of where S is completely inside B. So this pixel here, this 3 by 3 region is completely inside B, so I output a 1 here. Same thing's true for here, 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 here. I think that's it, right? Yes. Okay, so that would be the erosion of B with S. So that shrinks regions. In MATLAB, there are functions to do these operations. There's a utility function called strel for create a structuring element. You don't really need this. You could create your own, which is just a small binary image. But you could use the result S to in this im dilate function or an im erode function. So it's very useful to combine the erosion and dilation into a combined operation called opening or closing. So an opening operation is an erosion followed by a dilation. So we first do an erosion of B with S, which shrinks it, but then we re-expand the result with S. So we're not changing the overall size of regions. However, we do eliminate small holes and projections in the region. It doesn't give you back the original B. A closing operation is a dilation followed by an erosion. So we first expand B by S, and then we shrink it by S. And this fills in small holes and gaps. And in MATLAB, this is im open and im close. So this is an illustration of that operation on a binary image here, this shape. This shows the erosion of that shape with a disk structuring element. So we're just left with these pieces right here. You can see we've gotten rid of this bridge that used to be between the two halves. We then dilate the result with the same disk structuring element, which grows it back to the same size, but you can see we've lost that gap here. To show the closing operation, we first dilate the original shape with this disk structuring element, to get this, and then we erode it with that same disk structuring element. So that gets back to the original shape, except we've lost the sort of gap here that we used to have in the original shape. So here's an illustration of why that might be useful. Take this image, this original image, threshold it, and complement it. So we get the coins as white regions, but there are small black holes in them. So we can get rid of those holes by doing a closing operation. In this case, I used a disk of radius 5, and I got this here. If I had some small white regions in the background, I could get rid of those with an opening operation, if those regions were smaller than my structuring element. Okay, so now that we've found connected components and done this processing to clean up, get rid of small noise regions, we can extract properties of them. And these properties are things like area, total number of pixels in a connected component, the centroid, basically it's the location of the center of it, as you can see here. Or we can compute higher order moments, these second order moments that are shown here, mu sub RR, mu sub CC, mu sub RC. And these describe the shape of the region. For example, you could fit an ellipse to this and compute the principal axes of that ellipse. And that's actually given by the eigenvectors of the 2x2 matrix consisting of these second order moments. So MATLAB has a function to compute region properties called region props, which I'll talk about next. First, I want to mention that MATLAB has this structures concept as does C and other languages. So a structure is a variable with fields, and you can access those fields by giving the name of the structure and the name of the field. So the region props operation actually returns an array of structures. In this case, I'll call it blobs. So blobs, one of those elements of that array would have these fields called area, centroid, and bounding box. If I wanted to access elements, let's say take the second blob. So that would be blobs2.area. Okay, so that would be the area, that would be the value of the area of the second blob. Or I could take the centroid, etc. Oh, and let me point out the centroid and the bounding box. So the centroid, the centroid is the xy location. So this is a two-element vector where that's the x, or horizontal position, and this is the y, or the vertical position. The bounding box is a little different. Let me just draw a shape here. So this is, if this is my blob B, the bounding box is the rectangle that completely encloses this this blob. So the upper left corner is the first two elements. So this would be let's call it x0, y0. And then the other elements are the width and the height of the bounding box. A word about graphics in MATLAB. You can draw a rectangle on an image that's already been displayed using this function called rectangle. You say position, and then you give these four elements, which, just like the output of the bounding box, it's the rectangle. It's the location of the upper left-hand corner and the width and the height. And you can also give options such as the color of the border. You can also draw lines in MATLAB which connect two endpoints, x1, y1, x2, y2. So you give the starting and ending x coordinates, starting and ending y coordinates. So this actually looks, it's exactly the format of the bounding box variable here. let me just run that on the example I had earlier of this of these coins. So I have a white binary image region, and let me run blobs white. So I'll get BW label like that. Oh, I've actually already done that. Let me just run that again then. Okay, so that was my label image and the number of blobs. So I'll run region props on that, and I'll assign the result to blobs white. Okay, so what is blobs white? Blobs white, as you can see, is a structure. It's an array of structure of size 17. If I take the first one, you can see that it has 3 elements in it called area, centroid, and bounding box. Let me take the second one. Or no, let me do this. Let me find the largest blob. Okay. So to find the largest blob, I take the areas of all the blobs, which would be blobs white colon dot area, and you can see I have printed out the areas of all of them. So here's a really tiny one, and I have a bunch that are sort of all around 5,000 or 2,000 or something like that. Okay, so I'm going to put these in a list. The way I do that in MATLAB is I'll cat or concatenate them. So I'll say blobs white colon dot area. And what I've done is I've created a vector. This 1 indicates dimension 1, which is the vertical dimension, and I've listed all the areas in there. I can find the maximum by taking the max function. That returns the maximum, and it also returns the index of the array that has the maximum. So max area is 14,240, as we can see there. The index is 6. So blob number 6 had the largest area. So let's say I want to draw a bounding box around blob number 6. So I'm going to go back to my image. Well, let me show the original image here. Okay, so I'm going to take bounding box of blob number 6, okay, BB, which is that, and I'm going to draw a rectangle around with position BB, and I'll give it color, edge color red, let's say. Okay, so if you look in this image here, you see this red rectangle surrounding those 2 disks that happen to be joined. I could also draw a crosshair on the centroid using the line function. So let me get the centroid as blobs white index 6 centroid 1, and the y component would be blobs white of 6 centroid of 2. So the line function says take x0. I'll draw a line from -10 to +10, and y0 to y0, and with a color red, let's say. And I'll do the same thing for the vertical line, which would go from x0 to x0, y0, -10, oops, to y0 plus 10. Okay, so you can see the crosshair of the plus sign at the middle of that box there. And this is the MATLAB code.